Hey guys, welcome back to the channel. Today we'll be solving LeetCode 226 invert binary tree. So we're given the root of a binary tree and we want to invert the tree and return its root. So what does it mean to invert a tree? So in this case, every subtree of the tree is going to be reversed. So in this case, 2 was the left subtree and 7 was the right subtree, but 7 becomes the left subtree and 2 becomes the right subtree. And same goes for the subtrees below them. So there are 4 different ways to solve this, and they're all going to take a linear approach. I'm going to show you how to do it using a recursive depth first search. So let's get into the explanation. We're going to solve this by swapping the left and right subtrees at every node. So we start at the root node, and the left subtree is going to become the right subtree. And we can just do that like this. And now they're swapped. And then we're going to move, since it's a depth first search, we're going to go left, and then we're going to swap these subtrees. Then we're going to go left again, and we still swap them, but this won't throw an error because we will check if it's null. And then when we're done here, we're going to go here because we're going to go upwards, but we already did this. So now we're going to go right. That's how depth first search works. And we're not going to swap anything because there's nothing here. Then we're going to go to the right subtree and we're going to swap the following subtrees. Then we're going to go left again and there's nothing to swap, and we go right and there's nothing to swap. Note that we're going like this, and then we're done because we swapped everything, and we can simply return from the function. Let's get into the code. So we're going to start off by checking, is the root node null? And we can do that by asking if not root, and if it is, we're just going to return none. Now, the second if statement I'm going to add is actually an optimization, but it's not required. It's basically just going to check if both left and the right subtrees are null. And if they are, we can just return root, because we don't have to swap anything if they're both null because they're the same value. After that, we're going to swap the left and right subtrees, and Python has a special syntax that you can do this using one line, and it can be done like this. And so basically root.left gets set to root.right and root.right gets set to root.left. And after all that, we're just going to make 2 more recursive calls on each subtree so we can swap the subtrees of those subtrees. And after all that is done, we can simply just return the root, and this should work. This is all our code. We didn't need any helper functions. Oh, looks like I had a colon there. And as you can see, it's pretty efficient. This will run in linear or O of n time and has O of n space because we have to store all of the recursive calls in the stack. Thanks for watching.